Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 2, Section 6, titled Formulas. By the end of this video, you will have reviewed methods for transforming literal equations. Included are transforming geometric formulas and transforming equations containing only variables. Additionally, you will review some skills necessary for solving real-world problems. If you'd like me to cover any of these topics in greater detail, please leave a request in the comment section below. Please subscribe to this channel if you find the video to be helpful. Thank you. So before we get started, let's look at a definition. A literal equation. A literal equation is an equation involving two or more variables. It's pretty much that simple. A literal equation is an equation involving two or more variables. Formulas are special types of literal equations. To transform a literal equation, you solve for one variable in terms of the other or others, depending if it's one or more, two or more. This means that you get of the variable you're looking for, wanting to solve for, alone on one side, and the remaining variables fall in on the other. Okay, example 1, transforming geometric formulas. Okay, solve the formula for the area of a triangle, A equals 1/2 the base times the height, and solve it for the height. Okay, so right now it's solved for A. A equals, we want to switch it so it says H equals. And to do that, we're going to first, as always, write the problem first, write the equation that you're going to work on. That way you look back at what your problem is and what you're going to solve, so you make sure you're solving the right problem. Okay, then you multiply. Now, as you look at this right now, you see that we have 1/2 right here. Here's the half, right? 2. So in order to get rid of that half, we're going to have to multiply both sides by 2. So that's what we're doing here. We're going to multiply each side by 2. So you multiply the a by 2, and you're going to get 2a. And you multiply the half by 2, and the half is going to disappear. So we're going to get 2a is equal to b times h. Okay, so now we have to get the h alone, rather, excuse me. So what we're going to do is we're going to move the b. So we're going to divide both sides by b so we can get the h alone on one side. And when we do that, we're going to see right here, we're going to divide the bh divided by b, and we're going to divide the 2a by b. When we do that, we're going to end up simplifying here. We're going to get the h is equal to 2a divided by b. And now we have this area triangle, the 1/2 base times height, the area of a triangle, defined for h. Okay, so now you can, if you had the base and the area, you can find the height. Is what we're saying we're going to do here. Okay, here we are, example 1a. This is slide A of there's two slides that I'm using here to check your understanding. So the directions are: solve the formula for the perimeter of a rectangle. P equals 2 times the quantity L plus W. So 2 times the length plus the width. And to solve this equation, this formula for the W that we wanted to, if we had the perimeter and the length, we could use this formula we're going to create now to come up with the width. Okay, that's what we're doing here. So it's to check your understanding. So I'm going to ask you to pause the video and try this on your own. When you get back, we'll work it together, okay? Or we'll at least go over the steps together. So why don't you go ahead and pause it and do it, and I'll wait. Okay, so now I'm assuming you've done that and you're back here. So now the problem's laid out in front of us here. So what are we going to do first? We're going to solve the formula for the perimeter of a rectangle P equals 2 times the length plus the width for the width W, okay? So we start by writing the equation. The equation is the same thing that's up in the problem, right? So I rewrote the equation. P equals 2 times the length times the width. L is length, W is width. Then from there, we're going to try, we have to get the W alone on one side. Well, right now the W is involved through the distributive property here, so we're going to have to do something. So let's see what we're going to do. A couple of ways this could have been approached, but this approach is to divide both sides by 2 to get the P with the 2, okay, and the length and width alone on the right side by itself. So we're going to, the 2 is right here. We're going to divide by 2 on the right, and we're going to divide by 2 on the left. Okay, when you do that, we're going to get P divided by 2 is equal to the L plus W. So the 2 disappears here. This is gone. This is gone. All that's left is the L plus the W. So it's P divided by 2. And as you see, P divided by 2 is written this way now. We got the division symbol in here, right? Okay, so now we have P divided by 2 is equal to L plus W. So now what do? Well, we have to get the W by itself. So we have to move the L. And we do that by using the subtraction property of equality. So we're going to subtract L from both sides. So we have P divided by 2 minus L. And on the other side, it's equal to L plus W minus L. So you have L minus L. Those two cancel. And you get P divided by 2 minus L equals W. Here's your answer. W is equal to P divided by 2 minus L. Okay, example 2, we're going to just transform an equation. This is transforming equations. So all this is we're going to look at an equation here just to manipulate it, see how to manipulate it. In this case, we have an x and a y variable, and we're going to, this equation is solved for y, and we're going to solve it for x. That's what they want us to do. It's basically the same thing we just did on the perimeter problem. So let's look at it. We're going to write first we're going to write the equation. Y is equal to 5x plus 7. That's a linear equation, right? Y is equal to mx plus b, if you remember that. So we'll start by writing the original problem. And now what do? We have to get the x by itself, because now it's going to be something y is equal to x, right? So we're going to get the x by itself. In order to do that, we're going to subtract 7 from both sides using, what is that? The subtraction property of equality. And when we do that, we're going to get y minus 7 on the left and 5x by itself on the right, because these two 7s are going to cancel. So now we have to get the x by itself, which means to divide by 5, because we have to remove the coefficient. And we're going to either we're going to multiply by the multiplicative inverse, or we're going to we could say divide by 5. In this case, we're just going to divide by 5. And in doing so, we're going to see that we have 7 minus y divided by 5 is equal to 5 divided by 5 times x. It's because we've done these divide by 5s on both sides. And when we do that, the divide by 5s on this side, on the right-hand side, they disappear. And we're left with the x. And what's x equal to? Y minus 7 divided by 5. Okay, example 2, check your understanding. As you know, I'd like you to stop the video and try this problem on your own. All it says is solve the problem y minus 4 is equal to 3 times x minus 8, and solve it for x. So when you're done, it's going to be x equals something, right? So why don't you go ahead and do that, and I'll wait for you. I'll pause and wait for you. When you get back, we'll work on it together, okay? Okay, I'm assuming you've done that. So let's take a look at it. The first thing we're going to do is we're going to write the equation first. So we have y minus 4 equals 3x minus 8. And we're solving for x. Okay, so I look at this. Yes, I wrote down the problem correct. The worst thing you can do is write down the problem or not understand the problem, solve whatever you wrote down, and then find out at the end of the test, oops, I solved the wrong problem. So now we're going to get the x by itself. In order to do that, we have to add 8. We have to get the 8. We're going to move the 8 to the other side of the equation, okay? So we're going to say what? We're going to say, to move the 8, we're going to say y minus 4. We have to add 8 to both sides. Plus 8 is equal to 3x minus 8 plus 8. In this case, we use the addition property of equality, adding a plus 8 to both sides. And when we did that, we're going to find out that these two 8s canceled, and the negative 4 and 8 is going to give us 4. So now we'll have y is equal to 4. Oh, sorry. The y doesn't equal anything right there. I'm going to get this y y, y plus 4 is equal to 3x. Now we have to get the x alone by itself, which means we're going to divide both sides by 3. And in doing so, we're going to divide by 3 on this side, divide by 3 on this side, and these 3's now cancel because 3 over 3, right? 3 divided by 3 is equal to 1. So x is equal to what? X is equal to y plus 4 over 3. Okay? Now let's try this one. Solve transforming equations containing only variables. There's no numbers in this. It's just letters, just variables. So let's try this one, okay? So it says solve a times b minus d equals c. And we're going to solve it for what? We're going to solve for b. So the first thing we did is wrote the equation, make sure we're solving the correct equation, ab minus d equals c. That looks correct. So now what's the first thing we're going to do? We're solving for b, so that means we're going to get everything on the right hand side now except for the b. So first thing we're going to do is we're going to add d, a positive d, to both sides because we have a negative d and we want to move it and get rid of that negative d, right? So we're going to add a plus d on the left and a plus d on the right. And when we do that, we're going to end up with the d missing. These two d's are going to cancel. So we're going to have the a times b right here. This a times b is going right here is equal to c plus d because we added the d to the c. Now we have to get rid of what? We want to solve for b, so we have to get rid of the a, the coefficient a, in the ab term. And to do that, we're going to divide both sides by a. So we're dividing the left-hand side by a and the right-hand side by a. And when we do, we're going to get the a's are going to cancel. And we're going to get b equals c plus d divided by a. Okay, good enough? Okay, let's move on. Okay, problem 3, example 3, check your understanding. So as you know, I'd like you to stop the video and try it on your own. And the problem is what? M minus HP equals D. And you're going to solve it for P. So we want this to say P equals something. Okay, so why don't you go ahead and give it a try? I'll wait for you. Okay, so now that you're back, and I'm sure you've done your best, so let's go ahead and see where we're at. So we're going to start off by rewriting the problem down before we start. So we know what the problem is. M minus HP is equal to D, and we're solving for P. Okay? So what do? What's the first thing we're going to do? We need to get the HP by itself, right? Because we want to finally end up with the P by itself. So, and the rules are step 1 in solving these equations is you undo the addition and subtraction first, and then you undo the multiplication and division. So to undo the addition first, we have a plus m. We need to undo it with a negative m minus m. So we're going to do that. We're going to subtract m. We have a plus m here, minus HP, and that equals d. Okay, and we added a negative m, right? Negative m. So that's where we are now. And since we've done that, this is using the subtraction property of equality. You see now, by simplifying this, we're going to say that the m's, the minus m and the positive m, cancel each other, and we're left with negative HP, and that's equal to d minus m. So now the addition's taken care of and subtraction. So now we can move to the multiplication and division. So in order to move the h, we want the p by itself. In order to remove the negative h, we're going to, divide each side by negative h. And in so doing, we're going to say negative h on this side, negative h, and that is dividing this side is negative h. And then what are we going to get? From here, we're going to get the h's canceling and the negatives canceling on the left. So we have our p that we're looking for. Here's our p, okay? It says solve for p up here. And then we have, there's a negative h here, so I'm going to say negative the quantity of d minus m over h. But this is probably not as, we like to get rid of these parentheses if we can. So we can rewrite this and say that P is equal to the negative times the D and the negative times the M. Okay, so we're going to switch this. So it's going to end up being M minus D all over H. So P is equal to M minus D over H. Okay, example 4, a real world problem we're going to look at here. Okay, it says you can transform a formula so that it is in a convenient form for solving real world problems. So what this is saying is that we have a formula for one thing, but one of the variables is something we're looking for. So you can rearrange the formula so that you can now find the variable you're looking for in terms of the other variables that you already have the information on. So for instance here, the formula C, and this is going to be for centigrade or Celsius, is equal to 5/9 times the quantity F minus 32, and that's going to be the Fahrenheit, right? F is, so we're going to be converting from centigrade to Fahrenheit, okay, or Celsius. So this gives the Celsius temperature C in terms of Fahrenheit temperature F. Transform the formula to find the Fahrenheit temperature in terms of Celsius temperature. And then find the Fahrenheit temperature when the Celsius temperature is 30 degrees centigrade. Okay, so let's go ahead and start by looking at the first thing we're going to do is we're going to write the problem. Here it is. Celsius is equal to 5/9 times the quantity F for Fahrenheit in degrees Fahrenheit minus 32. And just like the previous, what are we going to do? We're going to multiply each side by 9/5. That's the reciprocal of 5/9. You'd flip it over, right? That's how you get the reciprocal of a fraction and multiply by the multiplicative inverse. Okay? In doing so, we're going to have 9/5 on this side times C, because we're going to multiply both sides by 9/5. And then we're going to have 5/9 times 9/5 times the quantity F minus 32. And you'll find out then that the 5/9 and 9/5 here, they cancel each other out. And we're left with 9/5 C is equal to F minus 32. So 9/5 times the centigrade is equal to the Fahrenheit temperature minus 32 degrees. So what are we going to do now? We're going to say 9/5 C plus 32 is equal to Fahrenheit minus 32 plus 32. Why did we do that? Because we wanted to get the Fahrenheit by itself, because we're trying to now solve for Fahrenheit from Celsius. So we add 32 to each side right here. So here's a plus 32 here and a plus 32 there. And when we simplify that, we're going to get 9/5 times the centigrade plus 32 is equal to the Fahrenheit temperature. Okay, the formula converted to find Fahrenheit from Celsius. And then it says, solve it for 30 degrees Celsius. So we do that. We write the formula. Fahrenheit is equal to 9/5 C plus 32. So what do we do? 9/5 times 30. We replace the C with the 30. And now, using PEMDAS, we have to do the multiplication and division first. Okay? And when you do that, you're going to get F is equal to 54 plus 32. 9/5 of 30 is 54. Okay? And then you can add the 54 and 32 together, and you get 86. So 30 degrees Celsius is 86 degrees Fahrenheit. Okay, example 4a, check your understanding. So solve this. So it says you can use the number, this is an interesting little problem. You can use the number of chirps a cricket makes in 1 minute to estimate the outside temperature in Fahrenheit, or F in degrees Fahrenheit. Transform the formula F equals n divided by 4 plus 37 to find the number of chirps in terms of temperature. So in other words, how many chirps per minute can you expect if the temperature is 60 degrees Fahrenheit? So the first thing you're going to have to do is probably do some manipulation and then come up with your solution, right? So why don't you go ahead and do it? This is check your understanding. Why don't you solve this and then, stop the video and then come back and we'll look at it together. Okay, so what are we going to do? Problem, you can use the number of chirps a cricket makes in 1 minute to estimate the outside temperature F in degrees Fahrenheit. Transform the formula F equals N divided by 4 plus 37 to find the number of chirps in terms of temperature, and N is the number of chirps. Now, how many chirps per minute can you expect if the temperature is 60 degrees Fahrenheit? So first, let's let F equal 60. We're going to substitute 60 for how many chirps, or um, how many chirps per minute. Okay, we're solving for N at 60 degrees. Sorry, I don't figure out what I was looking at here. Okay, so it says F, we're writing the equation. F equals N divided by 4 plus 37. Start by writing the original equation. Then we're substituting, we have the F is going to be 60, right? So 60 minus 37 is equal to N divided by 4 plus 37. So we had to undo the subtraction or the addition here, and we undo that by subtracting. So subtracting the subtraction property of equality. We're going to subtract 37 from each side. So now we have 60 minus 37 is 23. We simplified this, and so it's 23 equals N divided by 4. So how do we get rid of the 4 now? So now we have to multiply each side. So we have to say N times 4 divided by 4. Okay, so 23 times 4 right here is equal to N divided by 4 times 4. These 4's cancel, right? That's 1. So now we're left with N. So N is 23 times 4 is 92. 90N is equal to 92. So when that cricket chirps, when it's 60 degrees Fahrenheit outside, if you listen to a cricket, if you can isolate the cricket and listen to it, it should chirp about 92 times. Okay?